Okay, and another type of problem, the gas is, the number of moles of gas are changing, and so it's not constant. So what we do is use what's called the ideal gas law. Ideal gas law is PV equals nRT. And you rearrange this. R is PV over NT. P and V are the volume and pressure, as you know. N is the number of moles in the system. And again, the number of moles in the system can change, and that's why we use the ideal gas law. T is temperature in Kelvin, always. Okay, so R can have different values. I like to use the R value of 0.0821 liters atmosphere mole Kelvin. Okay, so when you have R equal to 0.0821, your volume must be in liters, your pressure must be in atmosphere, and as always, your temperature's in Kelvin, and moles is always moles. Now, here it shows that you can use a different type of unit for R, and the pressure in this case would be millimeters of mercury. So that's also an alternative. So let's look at a simple problem using the ideal gas law. And that would be problem 1184 is the one I did. Okay, it says a steel cylinder with a volume of 15 liters is filled with 50 grams of nitrogen at 25 degrees. What's the pressure of the nitrogen gas? Okay, you can see this problem is distinctly different than the problems that deal with the combined gas law. I don't have the gas changing conditions, meaning I don't have the change in volume or change in pressure and change in temperature of the gas. The gas is at a constant temperature, constant volume, and they want to know what that constant pressure is. And so they give you the number of grams of nitrogen, and from that you will be able to get the number of moles. Okay, so now I've worked this problem out. Okay, the ideal gas law. Okay, V is 15. The mass of the nitrogen is 50 grams. So now I've got to convert that to moles of nitrogen. And the molar mass of nitrogen would be 28. And that comes from, you look on the periodic table, 14 for the mass of nitrogen times 2 is 28. That gives me 1.8 moles when I divide 50 by 28. The temperature is 25 degrees plus 273 is 298. So what's my pressure? That was what was given in the problem. Okay, so in solving, PV equals nRT. I'm just rearranging first. So P equals nRT divided by V. My number of moles I calculated previously was 1.8. My gas constant is 0.0821. And my temperature is 298. And I divide by 15 to give me 2.9 atmosphere.